Hello and welcome to another lecture. In this lecture, we're going to talk about, we're going to do an example on calculating wind load on a 6-story hotel. We'll get into the spec in a minute. And there are MWFRS in both directions, which we're going to use chapter 27. I'll talk about that in a minute. And the design criteria is the building is located in Miami, Florida. Surface roughness is D. Topography not situated on a hill, ridge, or an escapement. It might be near the water. Risk category is 2. Enclosure classification is enclosed, and the structure itself is a steel reinforced concrete moment frame in both directions. So let's look at the building itself. It's right here. If you look at the plan view from the top roof, the building is 328 feet 9 inches long, and then east-west direction, and then north-south direction is about 75 feet 4 inches. On top of the building, there's a like air conditioning unit, rooftop unit, which is about 15 feet by 7 feet. And if you go look at the elevation view, it's a 6th floor. Each floor is about 10 feet tall, and the last floor is at 13.5. That makes a total of 63.5 feet tall, and the unit on top is 6 feet tall. And this is a north-south elevation view. All right, let's get to work. We're going to design it per minimum design load and associated criteria for building and other structure on ASCE 722. And wind is one of the ASCE is awesome. They are great, really. They has done a great job. They got 7 chapters dedicated just to wind load, from chapter 26 all the way to chapter 32. So if you could take a look at chapter 26, it's kind of talk about what type of procedures out there. And right here it says main wind force resistance system wind, which was the MWFRS, shall be determined using one of the following procedure. And it's a directional procedure for building of all height as specified in chapter 27. We're going to use this for building meeting this requirement. Then you have a procedure for low-rise building for chapter 28. Then you have a directional procedure on chapter 29. Then you have a wind tunnel procedure on chapter 31. You get it. So there are a number of ways, but the way we're going to use it, we'll make sure it meets the requirement before we do it. So if we go to so the first thing we're going to do, we want to make sure that meet the requirement. It says condition right here, building that is designed to wind load determined according with these. Building has a regular shape. So our building has a regular shape. It doesn't have any unusual geometric irregularity. And so that will meet that. And then we'll meet all these limitations. So first thing we got to do, we got to find out the basic wind speed. To do that, we can go to ASCE hazard tool. That might help us to find the wind speed. So come in, if we type in the location was Miami. We live in northern New Hampshire and it's very cold. I wish I had the Miami weather today. It's minus 20 degrees out there. So Miami. Okay, Miami, Florida, right there. And then they said the risk category was given, so it was 2. Risk category 2, and we're gonna click on the wind right there, and see view result. And if we look at the summary, see what we're gonna find right here. Basic wind speed is 169 mile per hour. Okay, since the speed is 169 mile per hour, that is bigger than 140 per ASCE, 26.12.31. Look it up yourself. And you can see that based on that, you have to provide some kind of a protection for the facade, which be the glazing in the building, and make them impact proof. All right, so we're going to go ahead and use these follow these steps to calculate the wind pressure. Step 1, we did determine the risk category which was given. Step 2, we just found out it was 169 miles per hour. Let's move on to step 3, determine the wind load parameter, wind directionality KD factor, and then we gotta find KZ, then we're gonna find the gust factor and all that stuff. We're gonna spend some time in step number 3. One of the things I recommend, go ahead and start your Excel. We're gonna do this in Excel. So get your Excel going. I will upload this Excel sheet in Brightspace. Make a heading like this one, design wind pressure. This is for 6-story hotel, and do all windward wall this way. So that's the wind blowing toward the building, and then leeward on the other side. And then we have the side wall, then we have the roof, and then we're going to type in CP. We'll calculate the later height of the building, KZ, QZ, and all this stuff, and we're going to work this. Let me go ahead and take all this out, and we can do it all together. Oh no, they're gone. All right. Then we're going to follow these steps which I showed you before. Step 1, step 2, one by one, we're going to figure it out. All right, one of the things we got to check, make sure, because this is a reinforced concrete rigid building, find out whether the building is rigid or flexible. This is step 3.00, I don't know, something. So if we go to this specification 26.11, let's go check this specification out. Where are you? You are right here. Okay, so this is a section 11.3. And right here it says limitation for approximate natural frequency as the alternative to performing an analysis to determine a new one. The approximate building natural frequency NA shall be permitted to be calculated in accordance with this section. But it has to meet this qualification. Number 1 is the building height is less than 300 feet. Our building height is what? 63.5. Yes, it is. And it says, is building height less than 4 times the effective length? Let's take a look at this for a second. Let me go ahead and make this. You should be able to see my screen right here. So step 1, it's going to be building height, H. Our H is equal 63.5, which is less than 300 feet. That's checked. And then the next one is, again, our height is 63.5. Is that less than 4 times L effective, which is 4 times, that was 75 in one direction. The shorter direction was 75.5, and that's going to be 301. So check that also. And if we go to the other direction also, it's going to be 4 times 300 and change. Was it 328? 328 point something, which still that's about 1100, 1315. So check that one too. So we meet the requirement because these limitations apply and are permitted to be used in A in both direction. Our NA, let's find out our NA comes out to what. Let me go back to the specification show ya. So NA, we made the specification for structural steel moment resisting frame. No, this one for concrete moment resisting frame building, NA is equal 43.5 divided by H by power 0.9. Okay, that's the one we're going to use right here. What? Okay, let me go back to my board again. So NA is equal, change color for good luck, 43.5 divided by H by power 0.9. So that's equal 43.5 divided by 63.5 by power 0.9, and let me use the calculator here. So that's equal 1.0, oh, just made it, 4 hertz, which is bigger than 1 hertz. That happened, we're gonna say since NA is bigger than 1 hertz, the building is rigid, defined rigid. Okay, so now we can go back, move to the other steps that we talked about. Okay, so far, so what we've been doing, we've just been following the steps on chapter 26. You come up here, we've been following chapter 26 to be using chapter 27. We did the basic wind speed, we got to do KD, and we got to do exposure factor. So let's go back to the PowerPoint here, and that's the step we are doing. So we did this step. Next step is determine the gust factor G. For building is permitted is 0.85 per ASCE 26.11, which we'll go in a minute. And also want to find out KD factor. And again, for this type of building, KD factor is also 0.85. So let's go look at those spec right there in a second. Was 26.11 gust effect right there. And there it is, and there's the equation we're looking for right here. Let me actually copy this equation. So this is the equation we're looking for. We find these gust factors right here, 0.85, and KD also came out to 0.85. And let's go back to the PowerPoint. What I have for the next step. The next step we're going to go ahead is determine the wind velocity pressure, which is basically those two equations I just did right here. And this is the equation. We make them bigger. There it is, QZ in imperial system. And then we're going to find the surface roughness given to us as D. The next step we want to find out the exposure category. It is assumed that the category D is applicable to all direction. Now, next step is going to be a little bit tricky. We're going to go ahead and use the ASCE 2611.1, calculate the alpha, and then we're going to use the equation, and that way we can calculate KZ. Let's just stay right here. Go back to the Excel sheet. In the Excel sheet, we want to put all the height in. Let's, I have the height in from before. Let me just copy and paste it. I'll explain in a minute. So we're going to go ahead and stem from the top of the building. Remember, our building is 63.5. We come to the next even number, which is 60. Then we drop every 10 feet all the way to 30. And from there, we're going to go 25 for good luck, and then 20 and 15, go 5 from 30 on. Then we get to the leeward, which is on the other side, which is all of them, and the sidewall on all of them. And the roof is 63.5. If we have a parapet wall, we can put that in. If not, we can just don't worry about it. And now when we have that, and this column we have a CP, which we're going to calculate. Right, our goal is to calculate KZ. Then we can calculate QZ. So let's go ahead and find out how we're going to calculate KZ. So to calculate KZ for 15 feet, and it says use KZ is equal to 2.41 times Z over ZG by power 2 over alpha. Then down here it says alpha and ZG are tabulated table 2611. So let's go to table 2611 and find those two numbers. Right here, D for customer unit, exposure D is 11.5. And our ZG is right there, is 1935. Let me write this down and we can go to our node. Let's go to the node so you can see what I do at the same time. All right. So we're going to go ahead and calculate KZ is equal 2.41 times Z, which is the height, divided by ZG, and time 2 divided by 2 divided by alpha. So in this case it'd be for example, and we're gonna say Z is at height of 63.5, right at the top from the spreadsheet. Okay, so now we're gonna have 2.41. Let me change it for color for good luck so you won't complain. 2.41 times 63.5 divided by 1000. What was that? 1900. Came out to be 1935 from the table, and alpha was we look at the table again. Alpha was 11.5. So 2 divided by 11.5. So if I put that in Excel on a calculator, it comes out to 1.33. So we need to put this equation right here into the Excel so we can calculate our KZ factor. So let's go back to the Excel right there. Okay, so I'm coming back in Excel right there, and I put the equation there. Go 2.41 times parentheses open. E10 is this one. The only variable we have is the height right here. The rest of them is basically the equation itself, and we're gonna go ahead and calculate. That became 1.32. Later on we can fix this. So I'm gonna grab this right here all the way to the bottom, right to here. See what we're gonna get. Okay, I got that, and then let's click away, and I want to fix this up and make sure we do a format the cell, go to the number, and then go ahead and make it to 2 is good. Click OK. So this is what we have so far for KZ. Okay, our next step is to calculate QZ. In order to calculate QZ, we got to find out KZT and we got to find KE. So this mini step right here, the topography factor, the building is not located on a hill or ridge or anywhere like this. So from ASCE 26.8.2 KZT is equal 1. Same as go for KE is equal 1. Then now we can go ahead and calculate QZ. Let's go back to the Excel sheet. Yeah, you see the Excel sheet right here. So QZ equation was right here. Let me put it over there so I can see it. And I'm going to go ahead and put the QZ equation right there. And that's going to be equal. Alright, so I put the equation in Excel was pain. It's right here, 0.00256 times KZ already calculated, and KZT, KE both 1, so we don't worry about that. V squared, I couldn't V squared, so I just squared it manually and multiplied by it, which came out to 28,561 for 169 miles per hour. And there's the result. Let's grab this all the way down to the bottom, see what we're going to get. And there's the QZ. Now we're going to move into the next step. Okay, our next, we're going to calculate CP. I tell you where I got these numbers. Let's go to table 27.3-1. Up here it says windward wall, all value CP is 0.8. That's why I had it on a spreadsheet. Then leeward wall, minus 0.5 from 0 to 1. We're just going to stick with that for now. Then side wall, all value is minus 0.7. Did I put that? Minus 0.7 side wall? No. So I'm going to be minus 0.7. Then the roof is going to be different. Now we're going to go ahead and calculate the CP for the roof. This is a little bit more complicated. And we're going to use this right here for the angle. Our angle is less than 10 degree and 10 degree or less. And then based on H over L ratio, it says normal to the ridge for theta bigger than 10, ours is less than 10. So for less than 10 degree, we're going to go ahead and divide the roof in 3 sections. 1, 2, 3. From 0 to H over 2, H over 2 to 2H. And then we're going to use this CP value right here. And it says from more than H, more than 1 ratio is going to be, you're going to use that. So let's go find out, do it using hand calculation. We're going to go north-south direction, wind blowing this way. So we're going to go ahead and divide the roof in 3 sections. Section 1, section 2, section 3. So I'm going to go for 1. 1 is basically from edge of the roof from here and from 0, let's say from 0, that's 2 H divided by 2. Our H is a 63.5 divided by 2, and that's a 37, no, 30, I can't do that, 31.75, I believe, our first section. Then our H over L, let's calculate our H over L, which we said it was 63.5, divide that by 75.3, that gives us 0.84. We knew that, so we're going to be between 0.5 and 1. So let me go back to show you where we are. You know, this steps has to be really followed carefully. For this 1, our CP says H over L less than 0.5. That gave us CP is equal 0.9, actually minus 0.9 and minus 0.18. For H over L bigger or equal than 1, our CP was equal minus 1.3 and minus 0.18. Okay, so one thing we got to pay attention to here is right here in this footnote here. It says you can reduce CP value if your roof area that you calculate is more than 1,000 square feet. Then use a factor of 0.8. Basically, take 0.8 multiply by this number right here to reduce the CP value. So let's say if we got our roof fall into that category. Coming back in here, and our first section, which is right here, this is a 37.175, and this, so the area is going to be basically 37.3 times 328.75, and that's equal 10,004. Oh, that's more than that. 10,430, which is more than 1,000. So we can reduce. I know this is kind of complicated, but be patient. So we're going to take 0.8 multiplied by 1.3. We're going to reduce this number right here, and that's going to come out to be 1 minus 1.04. Now we're going to replace this number right here with minus 1.04. So we're going to go ahead and find the linear interpolation. You know how you've done the linear interpolation many times. So what I'm going to do, I'm going to go ahead and go back to my Excel right here, and I have a linear interpolation. So we had 0.5 gave us 0.9, and then we had 1 gave us now 1.2. 1.2 was multiplied by 0.8, that became 104. 1.04, and then what's this going to give us? 1.9952, so that's 1. So now I'm going to come back in here. Okay, so for roof 1, CP came out to become 1. I'm going to go back up here to my spreadsheet, put in CP value 1 right there. Okay, let's go to the second roof. So second one is going to be, let me close this out. We go to the second. 2, make this different color so we can distinguish from it. There we go. 2 is going to be from H over 2 to H. Basically, it's going to be here. This section, this is H over 2, and this is H. Now, this is a plan view, by the way. So that's going to be from 31.75 to 63.5, which is the same thing basically. So now we're going to say CP value for 0.5, we had less than 0.5. CP value, where CP was equal minus 0.9 and minus 0.18. And then for CP value bigger than or equal to 1, our CP was, this is now, well, this is H over the other one. So is equal minus 0.7 to minus 0.18. Interpolate between them, that's going to become same thing, but what does this number come out? Where do I got these number? Let's go back to the code. Okay, so we have 0.7, 0.18, and the next one, the last one was 0.9 to 0.18. Between these two, H2 over H, that's for less than 0.5. For more than 1 became 0.7 to 0.18. And let's go back to the calculation. Actually, we'll go back to let's go back to Excel. So we can calculate through Excel. We can just go ahead and do a hand calculation. I'm going to go ahead and plug it in right here. We had 0.5. It was minus 0.9. And then for 1, it was 0.7. 0.7. And then we're going to get 0.76. So our number is 0.76. 76. Then we're going to calculate the last section of the roof. Let's go back to the writing again. So section 3 is from here on all the way to the edge. Let's change color so we don't mix up. Okay. And 3 is going to be from H, which is equal to 63.5, to the end of the edge of the roof, which is to 75.3. So for H over L less than or equal 0.5, our CP is equal minus 0.5 and minus 0.18. For H over L bigger than or equal 1, our CP is equal minus 0.7, that didn't change, minus 0.18. So now our CP comes out to be 0.7 and 0.5. Let's go back to the Excel. I was at 0.7. That's a 0.5, 0.5, and the other one stays the same, so it's 0.63, 0.64. So I'm going to come up here and make this 0.64. Okay. That was pain in the neck, but we got it done. This is the height. The height's going to be stay the same, so stay the same here, and therefore really kz is the same thing here. 1.33. I'm just going to put the number down. And for sidewall, and that's the same thing. kz is going to be the same thing. So that number right here is going to stand for all the way from here down. Paste that number. Oops. Paste it as a number. It should be same for all of these. The next thing we're going to calculate the external pressure. We have Q, we have GP, we have CP. And CP is right there. So QZ is right there. And G was, we calculated G. G was 0.85, remember? So I'm going to put down right underneath it 0.85. But anyway, I'm going to go ahead and here calculate equal. Okay, so we're going to calculate right here Q, which is right this. I just wrote it down, multiplied by 0.85, which is the CG, and multiplied by CP, and they give us this number. So let's drag this all the way down here, and that's going to become 5144. And down here, because our CP is different, that value is going to be different. So let's see if we can go ahead and continue it all the way down, see if it's going to work. Okay, we jumped into minus 41 all the way to, it should be minus 52, because these numbers right here I got, they should be minus. I didn't put the minus sign in it. Minus 1, enter. Let's just go ahead and retype it. Minus 0.76, enter. And that was 0.64 minus 0.64, enter. So the number looks much better. So these are the QGPP. And the internal pressure. Okay, now we're going to calculate the internal pressure, which basically be same all the way down here, because the equation is right here, QH times GPCI. And let's just go ahead and say equal, and then it's going to be the because all of it from the internal pressure coming from the top, so this number multiplied by 0.85 was G, and then multiplied by 0.18, enter. So this number is going to be same all the way through here. Perfect. So the next step we have is going to be plus this minus that. That means right here I'm going to have equal my pressure right here plus this, enter, and drag this all the way down, and here equal this number minus this, enter, there it is. So now we have this pressure build up right here, and from here on let's go ahead and see if we can go ahead and draw this on a board. Okay, so if I look at my Excel sheet, all this number. I'm going to go ahead and bring it back in here. Let me make this small so you can see a little bit. There we go. And we basically put the leeward pressure on this column right here. And then we put the windward. I'm sorry, windward. This was leeward on this side, and on the top was the internal pressure, which those number. You can look at the Excel number, and this is how the diagram comes out. Anyway, let's finish it up right here, and we can finish the rest of it in class. Have a good weekend.